So in this video, I want to talk about one of the example of SAT math problem, and the question is there is a XY plane and the O is the center of the circle and the measure of angle AOB is pi over 8 radians. What is the value of A? And before I solve for this question, let's just think about our solutions for that question. And at first, the first step, we need to memorize the special angles. So we need to memorize these special angles. And in the second step, we also have to know how to convert degree into a radian. And I want to talk about the difference between a degree and a radian. And they're just a ways of expressing the angles, but for radian, we are expressing it with a real numbers. And in the third step, we need to remember a Pythagorean theorem. And I'm going to use these things for our solutions while I'm solving for these questions. So at first, I'm going to talk about some tricks how to memorize these special angles. And this is quite useful finger tricks. And for here, there is two kind of thing. There is sine and a cosine. And the way to memorize it is that there are some special angles. And the formula for it, there should always be square root of something over 2. It is a formula. So that's why I inputted square root over 2 to every numbers. And the numbers that goes inside the square root, we're gonna be a dependent. So at first, let's think about it in this way. So I'm going to tell you an example that's what is sine of 0 degrees. Well, we pick this is a left finger, left palm, and for which is 0. And for the left side, it will going to be sine, and for the right side, it becomes cosine. What it means by that is that if you choose a finger, suitable fingers for it, 0 degrees, 30 degrees, 45 degrees, 60 degrees, as well as 90 degrees, and we pick a number that are formed by a suitable numbers, and then we see how many fingers left to the left side or the right side. And we think about it in terms of sine for the left side, the right side for the cosine. So let's think about it in terms of the sine of 0 degrees. So we pick 0 degrees right over here. But there's nothing left, which it will be 0 for sine. And I want to simplify this to see better for the original equation. So original formula. And for what about the 30? Well, the 30 will going to be 30 will going to be the second finger, which in this case, this one right over here. But for if you go left, only one left it. And if you go right, with 3 left it. So that means the cosine of 30 will going to be, we can input 3 to our value in the square root, which will going to be 3. And for the sine, only 1 left, so we can input 1 to the sine of 30 degrees. But and we can think about it in terms of cosine of 0 degrees. When cosine is 0, 4 of them left, so we can input our values in the square root, which is 4. And for 45 degrees, if we say it's 45 degrees, for the right is 2 left, and the left is 2 left. So the 45 degrees sine and cosine value we're gonna be same as square root of 2. Let's think about it in terms of 60 degrees. And for 60 degrees for the cosine, which is right side, there's only 1 left, so we can bring our 1 inside the square root. And for the 60 degrees, there's 3 of them left, so we can input our value of 3 into a square root. And then for 90 degrees, our last of them, in the right side there is nothing, which means the cosine, the square root inside the square root value, we're going to be 0. And for 90 degrees, for the sine, only 4 left, which means the value inside this the radical we're going to be 4. This is quite useful way to memorize these special angles of sine and cosine. So we can bring our whole informations down, and we know that the measure of angle AOB is pi over a radians. So that means the angle AOB is pi over radians. And we can make an exact right triangle by making a straight line from a point A, and we get a right angle, which means it's gonna become a right triangle. And we know that the lengths of the x-coordinate, that x-coordinate is square root of 3, which means the point from the y-axis and to the point A is square root of 3. And we know that that is the exact same thing with this one right over here because it is parallel. And we know that this side right over here, the length is square root of 3. And we can also find the value of y, and we know that from the y-axis to the point center point 0, that is exactly same with 1, and then this is parallel to this line, which means this will also going to be 1. And we found a two sides in a right triangle. That means we can find another side, and we can use Pythagorean theorem for it. And for the Pythagorean theorem, we know that a squared plus b squared, and that should be equal to c squared, where a and b are just legs and the c is a hypotenuse. And we can bring our whole informations down, and for a, we can bring square root of 3 squared from here. And then we can bring plus b squared as 1 squared. And that should be equal to c squared, but we don't know the value of hypotenuse. So we can simplify our equation, and we can see that square root of 3 squared is equal to square root of 9, plus 1 squared is just 1, and that should be equal to c squared. But square root of 9 is just 3, and then plus 1, and that should be equal to c squared. And then we can see that that means 3 plus 1 is 4. That should be c squared, which means the c is square root of 4, which is 2. So the value of c right over here will going to be 2, which means the radius of the circle is just 2. And then we can find a value. So we know that this angle right over here is a pi over a radians. So the angle should be pi over a radians. But before we do that, we can think about in terms of a thing that we did to memorize these special angles. And we know that we always put 2 in the denominator and we put square root. And the inside the radical, the thing that can go inside is number of finger. So we can bring that square root of something over 2. And inside the radical, we can use cosine or sine for it. And for cosine, I will use cosine for it. And it always starts from the hypotenuse and it goes all the way down. And we will see for a initial value of cosine. So it starts from the 2, which will going to be denominator, which is 2 in this case. And the ending line will gonna be a numerator, which is square root of 3. And according to a theorem that we learned to memorize the special angles, the inside a number of the radical we're gonna be a number of fingers left, which means it is a cosine, and that should be 3 left to the right, which means the value of 30 degrees we're gonna be our answer because it's 3 left from the right. So we can see that our value cosine of 30 degrees should be equal to square root of 3 over 2. So this is our second step, and the hypotenuse was the first one. And we can see that our value of cosine of 30 degrees is exactly the same thing with square root of 3 over 2. So that means 30 degrees should be equal to this angle that are converting to a radian, which is pi over 8 radians. And then we can talk about in terms of converting the degrees to radians and radians to degrees. And first of all, I'm going to talk about how to convert degrees to radians. And for terms like that, we know that 180 degrees is exactly the same thing with pi radians if you convert that degree to radians. And the formula for converting degrees to radian is that we can multiply degrees times 180 degrees, and in the numerator pi. The reason is because pi in the 180 degrees is exactly the same thing according to our theorem, and this will just cancel out as 1, but if you multiply with degrees, you're going to cancel out, and we can simplify in radians. So let's think about in terms of a 90 degrees. At first, we can calculate right over here. 90 degrees is, we can divide 2 to the both sides, and we get 90 degrees is actually 1 over 2 times pi. And let's think about in terms of converting our degrees to radians formula. So we can input our values of degrees, which is in this case 90 degrees, and then we can multiply pi over 180 degrees. But 90 degrees and 180 degrees, we're going to cancel out as 1 and a 2. And then we get, so 90 degrees is same thing with pi over 2, which is the exactly same thing that we proved right over here. And let's think about the second case where we convert radians to degrees. And for radians to degrees, we convert radians and we multiply the reverse one of a pi over 180 degrees to go to the degrees. So reverse of pi over 180 degrees, we're going to be 180 degrees over pi. But let's think about in terms of radians, which is pi over 2. And if you convert into a degrees, it should give us 90 degrees. So we can input our value of radian, which will going to be pi over 2 times 180 degrees over pi. The pi and a pi, we're going to cancel out as 1. The 2 times 180 degrees, we're going to cancel out as 1 and then 90 degrees, which is exactly the same thing with 90 degrees. And now we can simplify our version that we know that 30 degrees, so we know that 30 degrees is same thing with pi over 8 radians. Now we're trying to, let's convert 30 degrees into a radian so that we know the value of A exactly. And then the way to do it is multiply pi over 180 degrees to the degrees, which will going to be 30 degrees times pi over 180 degrees. And the 30 degrees and 180 degrees, we're going to cancel out as 1 and a 6, but that should be equal to pi over 8 radians. But the pi and the pi in the numerators are same, and the difference between the denominators is that A should be equal to 6. So we can say that our value of answer will going to be equal to 6. And the thing we need to remember is that this was kind of a good tricks to remember the special angles. And also we need to remember that the formula for finding or converting degrees to radians or radians to degrees. Moreover, we also have to remember the locations of the central angles. The central angles was in this case right over here. when we write C for the initial value of cosine. And then we also have to remember the locations of y-axis and the x-axis to find two values of a in a right triangle.